Select the numbers that are perfect squares. Now, a perfect square is when you have a rational number multiplied by itself creates the perfect square number. So for example, 64 is 8 times 8, and 8 times 8, that's multiplying the same number by itself to create this other number. So 64 is a perfect square. 20, that's 4 times 5, but you're not multiplying the same number by itself, so that's not a perfect square. 112, geez, I don't know about that one. Now, at this point, there are a couple different things you could do. You could make a factor tree where you could go 112 and then say it's 2 times 56 and then continue on down that way. Or it's an easier way using technology. So here's a calculator. And I want to know about 112. And really what I want to know is the square root of 112, because the square root is actually that number times itself that makes the perfect square. So 8 times 8, 8 is the square root of 64. So let's take a look. I'm going to find the square root key, which kind of looks like a division sign with a tail. And there you can see it up there. And then 112. Okay, now notice you have a decimal here. And this decimal goes on forever and doesn't repeat. And this is actually what's called an irrational number, the square root of 112. An irrational number cannot be written as a fraction of two integers. So here we go. This guy 112 is not a perfect square. Let's try 289 on the calculator. So I'm going to do the square root of 289. 17. So 17 times 17 makes 289. So 289 is a perfect square. Let's check that one off. And let's try 400. Square root of 400. You may know this one already. 20. So 20 times 20 makes 400, which means 400 is a perfect square. It also means that 20 is the square root of 400. So I'm going to mark 400 as a perfect square. Okay, now let's try 500. Square root of 500. 22.36 and so on. The square root of 500 is an irrational number. It has a non-repeating decimal that goes on forever. So 500 is not a perfect square. So here you can see the perfect squares are 64, 289, and 400.